University of New Mexico has existed since 1889. We are the flagship institution of the state. We have 78 master's programs and 42 doctoral programs. We have become noted not only statewide but national leaders in our engineering, our law school, our medical school. We have to continue to grow and provide those opportunities for the youth of New Mexico to get their education to go into those fields.
So STEM is an acronym for science, technology, engineering, and math. Primarily what's been classified kind of as the hard sciences, physics, biology, those classes that are traditionally viewed as science.
The STEM Gateway project was designed to provide a multifaceted approach to improving the outcomes for students, particularly Hispanic and low-income students at UNM, to pursue their gateway or entry-level coursework in science, engineering, and mathematics at UNM.
This grant was a partnership between Academic Affairs and Student Affairs, working with Gary Smith, who is out of Earth and Planetary Science. We had been working together on previous projects with our earlier Title V with peer learning facilitators. The grant was funded by U.S. Department of Education. We, as the flagship institution in the state of New Mexico, see it as a key role for us to make sure and do what we can to provide opportunities for the Hispanic, low-income, and first-generation students to be successful in the STEM fields. The grant from the U.S. Department of Education was funded at a tune of $3.8 million. This is a 5-year grant, which we have instituted several initiatives to increase the opportunity for students to be successful in the STEM fields.
Most universities, particularly most large flagship universities, have real problems with getting students to complete introductory STEM courses. Calculus, chemistry, physics are probably the biggest offenders, but biology, intro engineering courses may have the same effect. And if you can't get past your calculus, if you can't get past Newtonian mechanics or general chemistry, then this whole area is off limits, and you've lost out on a lot of possible career options.
The reason for STEM Gateway really goes back to UNM's data. So Tim Gutierrez, Gary Smith really took a deep dive into course success rates in entry-level STEM courses.
It wasn't that there was a lack of interest in STEM. There was actually a very high number of students that would register initially or that would state that their degree would be STEM oriented or STEM specific. But then as they tracked those students through the years, they found that about close to 50% of them switched degrees.
So of 1,500 first-time freshman students that declared themselves STEM majors from the periods of 2005 through 2007, when it came to the time of us doing the study in 2012, 23% of the students who originally identified themselves interested in STEM actually stayed and got a degree in a science, technology, engineering, or math field.
Our approach was to look at what really is the problem in having so many students, because we do find that the proportion of Hispanic students, for instance, that enter the science and engineering programs at UNM is very comparable to that for the Anglo students, but not their graduation rates. So we really wanted to try to improve that circumstance, and knowing that most of the students change their majors away from science, math, or engineering during the first 3 or 4 semesters, we realized the problem must really reside in the beginning experiences they have, which is why we named our project STEM Gateway, really looking at these gateway or entry courses into the major.
What the STEM Gateway program did was to come at it not from a standpoint of, well, we want to improve high school education, we want to improve study habits. Rather, we want to improve the pedagogy by making our method of presenting the material more compatible with the student's method of learning it. And in particular in the sciences, this means active learning.
So active learning, generally there is a small, very short period of lecture to give the foundational material, but there is some pre-learning requested ahead of time from the students. But then they use the course time to break out into small groups to answer some prompts that are put up for the students.
So the idea in active learning is to turn this around, turn the classroom not into a place for receiving information from the faculty member, but into a place where students can attempt to solve problems on their own with some guidance. We're not trying to cut them off entirely.
So you're having more activities, not just asking them clicker questions and seeing the responses, which I used to do, and I didn't know what to do with that information, but doing something like asking a student a question, or the whole class a question. They'll answer on their response systems, and then you won't show them the correct answer, right? Instead, you say, now convince your neighbor what it should be. Talk there, and they talk for a couple minutes in an active process, right? And then revote. And see if you changed your answer. Did your neighbor convince you that you were right or wrong or whatever? And then you look at those answers, and you're designing a question that the first time you ask it, about half the class will get it wrong, and half will get it right. If it's more than that, then it's too easy. Less than that, it's probably too hard. But you have a goal there for the first question, and then when they respond again, if more of the class did better, you get to 75% up or something like that, then you were successful, right? They learn from each other. And a lot behind that is the idea that, of peer learning. Students will learn from their peers.
This is my first class really taking a group setting. I always have lectures, one screen, one professor talking the entire time. And this is different because you're associating more. You get to elaborate more on what you're learning. You're not going in, getting the lecture, not being able to expand on it. In the group setting, you're allowed to question everything given and talk to your peers about it.
For me, the philosophy behind it is to get students engaged where they're not sitting and being passive learners. They're able to address certain things that aren't clear just right off the bat. So if I give a lecture on some topic and something's not clear, they're able to ask me right away before they even leave the class, or they're able to ask one of the PLFs that question. It's a chance for them to practice just really difficult problems. So I like to throw some spicy ones into the in-class activities and really give them a challenge where they've got sort of a safety net to practice working on something really difficult and see that. So just see the process they have to go through to solve something like that. So really it's just a way to get students engaged where I can see what they're doing and I'm able to help them quickly instead of them just being off and being lost.
I get comments kind of every semester that I've been doing this, that there are students who, a lot of the times this is their second or third time taking the class, and they always come up to me and say that they're so thankful that they have this opportunity because they weren't able to learn in a traditional classroom. But now that they have this active learning style, they actually can engage and see, do they know it, and get questions answered if they don't understand.
For me, one of the most important aspects, again, is community. That I think the active learning requiring students to collaborate with each other in the class, having PLFs there, myself being able to walk around the class, we build a community. They get to know their support systems, and they develop support systems amongst their peers. And sometimes I've heard students in groups berating a student for not coming the previous day and like, where were you? We needed you on that group assignment. And so I think that the students start to come to class for their peers, not just for themselves or for me. But I think that's a really critical piece, because if they're going to be successful in the STEM classes, a lot of that is showing up and doing the work during the times.
In my own experience, because I also teach other active learning courses, I find the approach to be incredibly effective if the student is willing to buy into the approach. I think they can acquire a much deeper understanding of the material and have, a better time at it. than is possible with the traditional lecture type approach.
It's much more fun to teach now. I've always enjoyed teaching, but I can do more of the parts that I like. The students, I think, enjoy it more, and they actually learn better, so I like it a lot.
Now, I really can't conceive of teaching without doing active learning. I'm just so glad that I was just a part of this, because they really opened my eyes to the effect this has on students, especially, you know, first generation students. They perform so much better if they're in this kind of environment. They're more included and they feel more engaged. So yeah, it's good stuff.
Lots of students who come into the university want to be scientists. They want to be engineers. They want to be computer scientists. They want to be doctors. The problem is they start taking their introductory chemistry, physics, geology courses, whatever it might be, and they struggle. And so then what happens is they end up dropping out and going into another major. What we want to do is help them be more successful in their gateway courses so that we can help them stay in the program so that we can graduate more STEM majors.
So one of the first things that we did in the course redesign project was looked at both kind of meeting in the middle, you know, working with a group of administrators to talk about what should we be going after? Where do you see the opportunities for us to make a significant change? And how can we institutionalize the changes once they happen? And then also working with faculty-sponsored or faculty-originated proposals where they came to us with those proposals. Now we brought those to that administrator group and said, what do you think about these proposals? And let's bring these together and see where we can go from here.
When I first started teaching at UNM, I basically had 2 semesters of lecturing where I was completely confused why none of my students seemed to be learning anything and why I could set a test that I thought would be easy and get a 50% average. So at the end of those, I found my way to the UNM faculty development. Gary Smith, who used to be with Office for Supportive Effective Teaching, helped me learn about that we actually do know about how to teach in a scientific way. We know quite a lot about how students learn and how students learn better.
A lot of the courses are very traditionally taught. You know, a professor gets up in front of the class and he lectures, and the students sit in the class and they take notes, and the students don't talk and the lecturer does. And labs, a lot of the labs were what you might call canned labs, where the students are given an activity and it's got a 98% success rate, and it's going to work, and they may learn something from it, but it's not really discovery. It's not learning how to be a real scientist and follow the scientific method.
So to improve our STEM gateway courses, in mine in particular in introductory physical geology, we redesigned the course so that it would be a focus on how students learn, help them engage in their learning instead of the stand and deliver content. The way to do that is we wanted to deliver some of the content before class, and then have students actually be prepared, come into class and work on in-class assignments, activities to help them engage in the material, to learn through practicing or applying.
In lecture, we've incorporated a lot more discussions and trying to discover the answer through conversation with your peers. And in lab, giving the students a problem that may or may not be solvable and giving them the resources to make their own conclusions and come up with their own hypotheses. And I think that there has been an increase in interest in what they're learning and what they're discovering and how they're learning it, because the students are taking a more active part and they can get excited about it.
Some of the challenges of redesigning a course is this going to work? What about the implementation? One of the things you learn when you're trying things out is after the end of class, you're like, that didn't work. So what are you going to do the next time? What are you going to change to make it better? And so part of it is implementing it, trying it out, hoping that your students are gracious to accept that, okay, that didn't work, and they too knew that it didn't work. And so trial and error is important, and also the students appreciating that you want to try something new.
The big challenge for me was I was kind of skeptical about the active learning thing and that new approach, and it kind of took us all out of our comfort zone. I know pretty much everyone on the math team was used to doing straight lectures and the whole Sage on the Stage business, and at first it was also hard for us just because it took a lot more work, and we also weren't convinced that it was actually going to work, and we were very concerned about being able to cover all of the material that we needed to cover. And these are kind of common complaints against active learning, and I think getting past that barrier, things were much easier after that, when we just realized that it is possible, it doesn't take that much more time, and the results are just really worth it, worth the extra effort.
The whole STEM Gateway process was a great opportunity for me. It really took my teaching to the next level. The opportunity to design a course from the ground up that was, from its very inception, going to be active learning, and just, had no need or desire to have any sort of lecture component to it. That was just, incredibly useful for me. And so I've used it in a lot of other aspects in my teaching since then.
Redesign is amazing because it has allowed us to keep the classes fresh and current, kind of move with this new style of learning, because it seems to work better with the generation of students that are coming through the university.
They're actually excited about it. The idea that when they come into class, they don't know what kind of activity they're going to get. It is not the same every single time, and that kind of brings them to the classroom. So one of the other benefits we've noticed about redesigning student-focused pedagogies is that more and more students actually attend class. And that's actually a big deal, because you can't pass a class you don't go to. And so getting them to class to see that there is value in that class is an important key.
The thing they showed us and the data that are out there, held up. So the students, perform better. They're being better prepared for later courses. The ones who are coming to us from courses that are now that are earlier in the curriculum, that have gone through redesign, the students are better prepared for what we're doing in class too. It's been an adjustment, but it's been fun, to do. And the worst case scenario is like the students didn't do any better, but they didn't do any worse. But most of the things we look at, they've been doing better. So, we've moved up. The goal was to get, have less people failing and, more succeeding, and that's really shifted, 5-10% up.
It's really getting the students to take an active part in their education and feel like they're contributing as they learn to be an actual scientist. So it's really cool to see the process happen.
One group that we need to step back and thank is the U.S. Department of Education, because without their support and their understanding of the importance of these type of programs, it would not be possible.
And that's one of the biggest challenges with federal grants that are of a limited cycle, that are 5-year grants, is if you're lucky and the university is flush with money after the 5 years, you can just fund those programs to continue.
What's really critical with projects like STEM Gateway is that they have the opportunity to initiate something, but it's really up to the institution to sustain those efforts. Otherwise, it becomes a flash in the pan that dissolves away in short order.
So what do we do with what we have learned from STEM Gateway? So even though we can't fund a PLF program, we've learned what makes a successful PLF program. And what we're seeing is there are departments at UNM that are specifically going after their own version of PLF. Maybe just with work study students, maybe with giving credit instead of pay to the PLFs. And even though those departments know that the money to do the PLF program no longer exists from this particular source, what we see is people dedicated to trying to find it, trying to find a way around a lack of money to continue what we have built through STEM Gateway and what they have built. Most of the people that are looking at continuing it were instrumental to making these programs work in the first place.
We here at the university are fortunate to have individuals who are willing to work together, go out and find the additional resources to try to have a greater impact on student success. There are many people to be thanked, from department chairs to the provost to the president, to just individuals who are the students who have served as PLFs. They have made a world of difference in this initiative. The partnerships between student affairs and academic affairs continues to grow and needs to grow so that we can make that larger impact on the student population.
So we are hopeful that the university administration will keep a focus on the importance of STEM support for faculty and students so that we can continue to build on the things that we learned during the STEM Gateway Grant and continue to keep those sorts of projects like the peer learning facilitators and the course redesign projects alive and functioning. What also needs to happen is for the faculty in the departments that were participants in STEM Gateway to keep the conversations going in their own hallways and offices, to keep drawing in their colleagues to participate in teaching approaches that the course redesign project faculty are involved themselves with. And we need the department chairs in those departments to help carry that banner and encourage their faculty to continue the good work in teaching that seems to have been inspired within them during STEM Gateway.